Welcome all. Today we'll see about the object model. In object-oriented technology, we have elements such as inheritance, polymorphism, abstraction, etc. These elements are collectively called as the object model. In the object model, we have four major elements: abstraction, encapsulation, modularity, and hierarchy. And there are three minor elements: typing, concurrency, and persistence. In this video, we'll be seeing about one major element, namely abstraction. Abstraction focuses only on the outside view of an object and it does not give details about how it will be implemented. Say for example, you take a car, we'll be concerned only about the outside view of the car. We will not be dealing with how the internal parts of the car work. Abstraction uses two principles. The first principle is the principle of least commitment, wherein the interface is given much importance and the internal details are not given importance. Say for example, you take an ATM machine, we give details about the interface, what we see on the screen, and how it is implemented, how each key is implemented will not be given importance. The second principle is the principle of least astonishment. Suppose I give 2 and 2 as input. When I add 2 and 2, I should get 4. It should not give me the wrong result and it should not lead to any other side effects. Take the client and server. The server object has a lot of resources. The client object utilizes these resources. The behavior of an object will be defined by the operations performed and the services it provides to another object. Now this gives rise to a model called the contract model. Now what is the contract model? The contract model defines the responsibilities of an object. It includes the signature and the protocol. Now the signature refers to the function header. As shown in the picture, the signature includes the function name, the function parameters and return type. That is the first line of a function. Protocol denotes the operations and the rules to be followed. It gives details about how an object can act or react. Invariance. An invariant is a Boolean condition. It is of two types, preconditions and postconditions. As you can see in the diagram, preconditions are invariants assumed when we give input to the software component. Postconditions are invariants that must be satisfied when we get the output from the software component. In case the precondition is violated, it means the client has not followed the contract and the server cannot proceed with the function. If a post condition is violated, it means that the server has not followed the contract and therefore the client cannot trust the behavior of a server. Apart from these two, when a function is performed, there can be side effects called exceptions whenever a condition is not satisfied. All abstractions have two properties, static as well as dynamic. Take a file for example. The static property can be the file name, the size of the file, and what it contains. The dynamic property can be the change in the size of the file, change in the name of the file, or change in the contents of the file. The dynamic properties for the different types of programming are given below. When it comes to procedure-oriented programming, changes can happen when a main function calls a subprogram. In rule-oriented programming, changes can happen when one rule triggers another rule. In object-oriented programming, changes can happen when an object's function is performed. Now we'll see an example of abstraction. Consider a hydroponics automated gardener. It is designed to reduce the human efforts needed to grow plants. The abstraction we'll be considering in this example is that of a sensor. Consider the temperature sensor. It is responsible for measuring the temperature in a particular location. The function of the sensor is to record the temperature and when asked, it must report the temperature. This is the abstraction for temperature sensor. In the first two lines, you can see the keyword typedef. Typedef can refer to a primitive data type like integer, floating point, etc. Temperature is defined as a floating point number and location is defined as an unsigned integer. The class name is temperature sensor. It has a constructor with location as parameter. It has a destructor tilde temperature sensor. It has a function calibrate. It has a client object named current temperature to operate on the temperature sensor object to find the current temperature. In the example, temperature sensor is the class name. It takes location as constructor parameter. We create objects like greenhouse 1 sensor, greenhouse 2 sensor. Greenhouse 1 sensor takes location 1 as its parameter. The 1 refers to the location. Greenhouse 2 sensor takes location 2 as its parameter. Regarding the invariance, the precondition can be related to the location, that it has a valid location, and post condition can be related to the unit of temperature, that the temperature value returned is in Fahrenheit. The abstraction we have described so far is passive, that is, it does not act on other objects. We can make it active by making it act on other objects. In the passive type, the sensor reports the temperature only when asked. We can modify it to be active by giving a set point. So whenever the temperature crosses the set point, the server immediately runs a callback function to report the temperature to the client. The callback function is named active temperature sensor. It has a constructor with two parameters, location and temperature. Now earlier we saw that in the passive type, the constructor takes only location as the parameter, only one parameter. Whereas here, the active type takes location and temperature as the parameter. There is a function establish set point to set the critical temperature. Based on the set point, whenever the temperature goes below or above a set point, the active temperature sensor object calls the callback function. The callback function sends a report from the server to the client. On receiving this report, the client can respond to the condition. I hope you found this video useful. Thank you.